So in section 9.2, we'll discuss about the critical value approach. And in section 9.3, we'll discuss about p-value approach. So what is the critical value approach? So we already know when we do hypothesis testing, first we need to write the hypothesis, right? First we need to write the null hypothesis and alternative hypothesis. So since we are doing hypothesis test for one population mean, so our parameter is mu. So we'll have either mu less than, sorry, the null will be always equal. So mu equal mu 0, and alternative will be either less than or greater than or not equal. So we'll have three hypotheses based on the alternative. Okay, so for critical value approach, so we'll find the critical value for a given level of significance. So what is the level of significance? Level of significance is the probability of type 1 error, which is alpha. So for a given alpha value, we can find the critical value. So what is the critical value? So we have three types of hypothesis tests, right? One is left tail, right tail, and both tail or two tail test. So the left tail, this is mu is equals to mu 0, and this is mu less than mu 0. So for left tail test, the critical value is negative z alpha. So this is the critical value. So that's mean the z score for a given alpha, and for left tail it is negative z alpha. So this is our critical value. So the critical value for the left tail will be negative. And for the right tail test, the critical value is, for a right tail test, mu is equal mu 0, and alternative is mu greater than mu 0. So for this one, the critical value is z alpha. So this is positive value. So this is the critical value. This is the z score for a given alpha value. And for two tail test or both tail test, so mu is equal mu 0, and alternative is mu not equal mu 0. So for this one, we'll have actually two critical value, because actually we'll have two rejection regions. So one will be on the left and the other one will be on the right. So we'll have negative z alpha over 2 and z alpha over 2. So that's mean we'll have two critical value in this case. So in this case, our critical values will be negative plus minus z alpha over 2. So that's mean we'll have two critical values. One is positive z alpha over 2, and the other one is negative z alpha over 2. Okay. So what is the rejection region and non-rejection region and critical value for? Okay. So we can find the critical value. Then we'll determine the rejection region and the non-rejection region for the hypothesis test. So for a left tail test, the rejection region will be always on the left side. So we need to just find the critical value, which is negative z alpha. And this region, the left side on this critical value, is called the rejection region. This is the rejection region. And this one is the non-rejection region, or will do not reject if our test statistics is in this, falls in this region. So this is the critical value. Okay. Excuse me, so please
the coolest thing ever.
unmute your microphone.
A little bit. He's basically saying Tom Brady really wants the football. So, like I said earlier, you can't say no to Tom Brady.
I think Logan is talking. So could you please mute your microphone?
He's the one who earned it. I just got lucky happened to be there at the right time. Byron,
Okay, so for hypothesis testing, if you want to use the critical value approach, you need to find the rejection region, non-rejection region, and critical values. So what is the rejection region? The set of values for the test statistics that leads to rejection of the null hypothesis. So in hypothesis test, actually we have a claim and we want to test that claim, or we want to test a statement and which we assume to be true. So to determine the rejection region, first you need to find the critical value. So for a left tail test, the critical value is negative Z alpha. And on the left side, this is the rejection region for left tail test. Okay, so for right tail test, this is positive Z alpha. So this region is the rejection region. And for two tail test, we have two rejection region. This one, this is Z alpha over 2, and this is negative Z alpha over 2, and this region. And this region is called non-rejection region. This region is also called non-rejection region. And this region also is called non-rejection region. For left tail test, this is the critical value. For right tail, this is the critical value. And for two tail, we have two critical values. Okay, so here is the graphical display of the rejection regions for left tail, right tail, and two tail test. So this is the rejection region and this is the non-rejection region. Okay, so now how do we take our decision? We calculate the test statistics, which is called Z observed or just Z. So the test statistics is X bar minus mu sigma over square root of n. And this is for null, we assume null hypothesis is true, so it will be mu 0. And similarly here, we consider X bar minus mu 0 sigma over square root of n. So this is the test statistics. This is also Z score. So we calculate the test statistics using the data we collected, and we have the rejection region. Now we will see where this Z score falls. So if it falls in this region or in this region, then we'll reject the null hypothesis. If our test statistics for left tail test, if it is in this region, then we'll reject the null hypothesis. And for right tail test, if our test statistics is in this region, we'll reject the null hypothesis. Okay. So here, this is the same thing, the rejection region for left tail, right tail, and two tail test for a given alpha. So this is for right tail, this is positive Z alpha. For left tail, this is negative Z alpha. And for two tail, this is negative Z alpha over 2 and Z alpha over 2. Yeah, so you need to remember this. So for one tail, it will be always Z alpha for right tail. And this is negative Z alpha. But if we have two tail, then it will be negative Z alpha over 2. And this is Z alpha over 2. So we'll have two critical values. Yeah. So when you will be calculating the critical value, so you should know when we use Z alpha over 2 and when we use Z alpha. Do you have any question? Okay, so if you do not have any question, then we'll go over some example. So here the graph to the right portrays the decision criterion for a hypothesis test for a population mean mu. The null hypothesis of the test is H0 mu is equals to mu 0. So here the null hypothesis is mu is equal mu 0. Okay, so the curve in the graph is the normal curve. So we have the normal curve for the test statistics under the assumption that the null is true. So we always calculate the test statistics under the assumption that null is true. So we consider null is true, then we collect data and we calculate the test statistics. So if the test statistics falls in the rejection region, that's when we reject null. So that's mean the data didn't come from the null distribution. Okay, so part A, determine the rejection region. So we need to determine the rejection region. So what is the rejection region here? So here the rejection region is this part and this part. So this is the rejection region. So then determine the, okay. Determine the non-rejection region. So the non-rejection region is this one, the middle one. And determine the critical value. So here the critical value is, this is the critical value and this is also critical value. So here the critical values are plus minus 0.915. And determine the significance level. So what is the significance level? So here it is given this area is 0.09 and this area is 0.09. So what is the critical value? So this is Z alpha plus minus Z alpha over 2, right? And here this value is alpha over 2 and this value is also alpha over 2. So what is the value of alpha then? So alpha is the level of significance or significance level. So alpha over 2 is 0.09. So alpha will be 2 times 0.09. So it will be then 0.18. So this is the level of significance in this case. Okay, so here determine the critical values for a one mean Z test. So we have to determine the critical value. So draw the graph that illustrates your answer, a left tail test. So here the test is a left tail test. So that's mean our hypothesis is mu is equal mu 0 and alternative will be mu less than mu 0 because this is a left tail test. So now we need to draw a graph, the normal curve, and where alpha is 0.05. So alpha is 0.05. So since this is left tail test, so the critical value will be negative Z alpha. So it will be negative Z alpha. Now to find the critical value, we need to look at the Z table. So if we look at the Z table, so let me look at the Z table. Okay, so this is the Z table. So what was our alpha value? Alpha was 0.05. So now we need to look at 0.05. So let's look at 0.05. So where is 0.05? So this is 0.01, 0.009, 0.01, 02, 03. This is 0.05 and 0.0495. So 0.05 is in between these two numbers, right? So in between 0.0505 and 0.0495. So then the z-score will be, corresponding z-score will be negative 1.6. So this is 4 and this is 5. So the average of these two numbers will be, so then the z-score will be negative 1.64 and negative 1.65, average of these two numbers. So if we take the average of these two numbers, then it will be negative 1.645. So this is the z-score if alpha is 0.05. So this is our critical value. This is critical value. Okay. So now the rejection region is this region. This region is the rejection region. So we'll reject null in this region. So that's mean we'll calculate the test statistics. So if our test statistics is a value which is less than negative 1.645, then we'll reject the null. If the test statistics is greater than this value, negative 1.645, we fail to reject null. We fail to reject null in this region. So that's mean if our test statistics is somewhere here, then we'll fail to reject null. But if our test statistics falls here, then we'll reject the null hypothesis. And similarly for the right tail test, here the alpha is 0.02. So we need to find the critical value. So the critical value is z alpha. Then we need to look at the z table. So here is the z table. So 0.02. So where is 0.02? 0.02. This is 0.01, 0.019197. So 0.02 is a number between these two values, right? 0.0202 and 0.0197. And the corresponding z-score is negative 2.5 and 2.6. So that's mean the average will be negative 2.55. So the average of z-score is negative 2.55. Now the question is, can we consider negative value in this case? The answer is no, because this is right tail test. So the critical value will be positive. So that's mean this one will be 2.55. So this is the critical value. So now we'll calculate the test statistics. So if our test statistics is greater than 2.55, for example, if the test statistics z is 3.2, then we'll reject the null, right? Because it will fall in the rejection region. But if our z is, for example, 2.1, then it will be somewhere here, which is less than 2.55. So that's when we fail to reject null. We do not reject null in that case. Do you have any question? Okay, so let me give you some more example. Okay, for example, the alpha is 0.05. The null hypothesis is mu is equal 30, and alternative is mu less than 30. And test statistics is this is the test statistics, 1.69. So now we'll find the critical value. So what will be the critical value in this case? The critical value is negative z alpha, right? Because this is left tail test. This is left tail test. So the critical value will be negative z alpha, and alpha is 0.05. So if you find the critical value, then it will be negative 1.645. So this is the critical value. And that this is the test statistics. This is test statistics. Statistic. Okay. Now the question is, do we reject null or fail to reject null? In this case, do we reject null or fail to reject null? So what do you think? So do we reject null in this case or fail to reject null? Anyone? Okay. So I got two responses. All of you are saying okay. I also got failed to reject null. Yeah. So I got reject null and also failed to reject null. Okay. So which one is the correct? Okay. So what is the rejection region here? This is the left tail test, right? So that's mean this region is rejection region. Will reject null if the test statistics is somewhere here. So what does it mean by test statistics is somewhere here? That's mean the value of z, this value is less than this number, less than negative 1.645, right? If the test statistics is less than negative 1.645, then it will be somewhere here, right? But this value is 1.69. So 1.6, this is 0. So 1.69 will be somewhere here, right? And this region is FTR. That's been failed to reject null. So now what do you think? Do we reject null or fail to reject null? Yes, we fail to reject null hypothesis, right? Yeah, that's correct. Because the test statistics is in the non-rejection region. Let me give you one more example. So if we have two-tailed test, mu is equal 100, and alternative is mu is not equal 100. So that's when this is two-tailed test. Alpha is 0.10. So that's when the level of significance is 10%. Yeah. And the test statistics is 1.82. This is the test statistics. This is test statistic. Okay. And let's draw the normal curve. So this is our normal curve. And since this is two-tailed test, so we'll have two rejection region. So this one will be negative z alpha over 2, and this one will be z alpha over 2. So what is the value of alpha over 2? So alpha over 2 is 0.1 over 2. So that's mean 0.05. And we already know the critical value for 0.05, which is 1.645. So that's mean this value will be the negative 1.645, and this value will be 1.645. So this region is rejection region, and this region is also rejection region. So now our test statistics is 1.82. So do we reject null or fail to reject null? What do you think in this case? So do we reject or fail to reject? So first look at the rejection region. This is negative 1.645, and this is positive 1.645. We have two rejection regions. One is on the right side and the other one is on the left side, because this is two-tailed test. So now we have the test statistics 1.82. So if it falls in the rejection region, we'll reject the null. That's mean if this value is either in here or if this value is somewhere here, then we will reject the null. But if the value of z is somewhere here, then we'll fail to reject null. Yeah, in this case, we'll reject the null hypothesis, right? Yeah, that's correct. Because 1.82, 1.8, this is 1.645. So 1.82 will be somewhere here, right? So that's mean the test statistics is in the rejection region. So we'll reject the null hypothesis. Yeah, this is called the critical value approach. That's mean we'll make our decision based on the critical value. So we'll compare the critical value and the test statistics. Okay. The next one is p-value approach to hypothesis testing. So we can make the same decision based on the p-value. So in the previous case, we didn't calculate the probability, right? We didn't calculate the p-value. But here in this case, we'll find the probability for the test statistics, and we'll compare the probability with the alpha value, with the level of significance. So this is called the p-value approach. So in the previous case, we just compared the test statistics, and the critical value. So in the case of critical value approach, but for p-value approach, we'll calculate the p-value and we'll compare with the alpha. So we'll compare these two values in this case. So how do we calculate the p-value? So for the left tail test, we can calculate z observed or z test, the test statistics, right? Or for right tail or for both tail, we can calculate the test statistics. Okay, so for left tail test, the p-value is probability of z less than z observed, or the test statistics. This is called z OBS, z observed. And for the right tail test, the p-value is z greater than z observed. And for two tail test, the p-value is 2 times probability of z greater than absolute value of z observed. So this is the p-value for the two tail test. So this is p-value for one tail, left tail, this is for right tail, and this is for two tail test. So what is actually p-value? So p-value is the p-value of hypothesis test is the probability of getting sample data at least as inconsistent with the null hypothesis. Okay, so what does it mean actually? So we can calculate the z observed or test statistics, which is x bar minus mu 0, and this is sigma over square root of n. So we can calculate this one. If our test is left tail test, then the p-value is probability of z greater than, z greater than z observed or the test statistics. So that's mean we'll calculate if our z observed is somewhere here. Oh, so this is left tail, so we'll do actually the opposite. We'll do z less than z observed. So we'll actually do this, z less than z observed. Okay, so what does it mean? That's mean if our z observed is here somewhere, that's mean we'll find the area of this region. So this area is called the p-value. And similarly for right tail test, so if we have a right tail test, let's consider a right tail test. Okay. So H0 is mu is equals to mu 0, and H alternative is mu greater than mu 0. Okay, so in the following chapters, in chapter 10 and chapter 11, so we'll do the hypothesis test, but we'll do hypothesis test for unknown sigma, and we'll do hypothesis test for more than one population mean. We'll do hypothesis test for 2 population mean. But if you know the basic structure of the hypothesis testing, then you will understand the following chapters. But if you do not understand this chapter, then you will not be able to go with the following chapters. You will not be able to understand the following chapters. So that's why you need to understand each and every line of this chapter. So that's mean what is hypothesis and what is null, what is alternative, how do we determine the null, and how do we determine the alternative, and how do we make our decision. So there are two type of approaches. One is critical value approach, and the other one is p-value approach. So what is the p-value of critical value approach? What is critical value, and how do we make decision by comparing the critical value and the test statistics? Then how do we calculate the p-value? So you need to understand all of this. So if you do not understand this, then you will not be able to understand anything in the following chapters. Okay. So if you do not understand anything, please let me know, and you can ask any question. If you have any question, you can ask. Yeah, I'll try to answer your questions. Yes. Because I want to make sure that you understand everything, the basics of the hypothesis test. Okay, so let's consider a right tail test. And our test statistics is z observed, which is x bar minus mu 0 sigma over square root of n. So this is our test statistics. So since this is right tail test, our critical value is z alpha. Okay. So let's draw the normal curve. So z alpha will be on the right side, right? So this is our z alpha. Okay. Let's consider z alpha is 1.64. Yeah, let's consider z alpha is 1.64. And let's consider test statistics is 1.52. Okay, so now how do we calculate the p-value? So where is z observed actually? Z observed will be somewhere here, right? Z observed will be somewhere here because this is 1.52. So, and the critical value is 1.64. So 1.52 will be on the left side of 1.64, right? So it will be somewhere here. Okay, so what is the p-value? So the p-value is probability of z greater than z observed. So this is 1.52. Sorry, this is 1.52. So what does it mean by probability of z greater than z observed? That's mean probability of z greater than 1.52, right? So that's when we are looking for the area of this part. So we are looking for this area. Okay, so this area is alpha, and this area is called p-value, the area for the test, the probability for the test statistics, right? This is called p-value. Okay, so let's consider the previous approach, the critical value approach. So we know we have the test statistics and we have the critical value. So based on the critical value approach, so what should be our decision? So do we reject null or fail to reject null? So what do you think? So based on the critical value approach, so do we reject null or fail to reject null in this case? Okay, so look at the test statistics. So this is the rejection region. So where is the test statistics? Is it in the rejection region or non-rejection region? So the shaded region is the rejection region. So if the test statistics is in the shaded region, then we'll reject the null. If it is outside the shaded region, we fail to reject the null. So what do you think? Do we fail to reject the null or reject the null? We fail to reject the null, right? Because 1.52 is outside the rejection region. Yeah, thank you. We fail to reject the null. Okay, now the question is, so what will be the p-value? P-value is the area of this part from here to here, this area, the shaded region, and also this area. Okay, so let me shade it different way. So maybe I can shade it in this way. Yeah, this is the p-value. So which area is larger, the p-value or the alpha? Alpha is the area on the right side of 1.64, and p-value is the area on the right side of 1.52. So which area is larger, p-value or alpha? Okay, so if p-value is larger, write p, and if alpha is larger, then just write, you can just type a. So if you think p-value is larger than alpha, then type p, and if you think alpha is larger, then just type a. Okay, so let me get your answer. So what do you think? Which one is larger? If p is larger, type p, and if a is larger, type a. Okay, that's great. Thank you. Yeah, so p-value is larger. So what was our decision? Our decision was we failed to reject null, right? If you remember from the critical value approach, because 1.52 was outside the rejection region. So that's when we failed to reject null. And you can see that the p-value is larger in this case, right? So that's mean if you compare p-value and alpha, if p-value is larger than alpha, then we fail to reject null. And you can see here why p-value is larger, because this is p is outside the rejection region. So actually it contains more area, right? So when we fail to reject null, so p-value has more area compared to alpha. Okay, so now you can, I think you'll be able to remember. So when we reject the null in p-value approach, so if p-value is larger than alpha, so actually I showed you this example so that you can relate with the critical value, the p-value and critical value. Otherwise, if you just memorize the fact that if p is greater than alpha, we fail to reject. If p is less than alpha, we reject null. Then yeah, after maybe a few days, you will forget everything. But if you can relate the p-value approach and the critical value approach, then you will never forget. Okay, so let's consider another example. So for example, we have h0 mu is equals to 20, and we have alternative mu is okay, let's consider less than. So is alternative mu is less than, sorry, less than 20. Okay, alpha is 0.05. So the critical value will be, let's consider the critical value, negative z alpha, which is negative 1.645. Yes, sure. Can you repeat what we just said about p greater than alpha? Yes, I'll repeat that one. Thank you. Yeah, good question. Okay, so if you look at this example, so we found that the p-value is greater than alpha, right? And our decision was fail to reject the null. So that's mean when p-value is greater than alpha, we fail to reject null. If p-value is less than alpha, we reject the null. So why do we reject the null when p-value is less than alpha? I'm going to show you now. Okay. So, and consider the test statistics z observed is negative 1.90. So this is our test statistics. So this is our rejection region. Okay. And this area is alpha. The shaded region is alpha. So what is the p-value here? The p-value is probability of z less than negative 1.9 because our test statistics is negative 1.9. So when should be negative 1.9 located? So it should be located somewhere here, right? Because this is negative 1.645. So negative 1.9 will be on the left side of this number, right? Because negative 1.645 is larger than 1.9. So this number is negative 1.9. So this area is p-value. So this area is p-value. So this is p-value. Okay. So forget about the p-value approach. Think about the critical value approach. The test statistics is negative 1.90 and critical value is negative 1.645. So what do you think? What should be our decision in this case? Should we reject the null hypothesis or fail to reject? Or you can say, like, where is the test statistics? Is it in the rejection region or non-rejection region? Yes, we reject the null hypothesis, right? That's correct. Because negative 1.9 is in the rejection region, right? It is on the left side of negative 1.645. Okay, so what about the p-value? So is it greater than alpha or less than alpha? That's mean this area is less than this area or greater than this area? Alpha is the area from here to here. This one is the alpha, and p-value is the area from just here to here. This is the p-value. So which one is larger, p-value or alpha? Yeah, p-value is less than alpha, right? So p-value is less than alpha or smaller than alpha. So, and we rejected the null hypothesis, right? So here p-value is less than alpha and we rejected null hypothesis. So now you can see why do we reject null hypothesis when p-value is less than alpha? Because when p-value is less than alpha, that way in that case the test statistics falls in the rejection region. So that's why we reject the null hypothesis. So is it clear now? So when do we reject the null hypothesis? Or why we reject null hypothesis when p-value is less than alpha? And why do we fail to reject null hypothesis when p-value is greater than alpha? So is it clear? Or do you have any question? Okay, that's great. Okay. Okay, basically from this chapter you need to understand this, like when we reject the null hypothesis and how do we perform the hypothesis test. Okay, so p-value of a one mean z-test if the test is two-tailed. I already discussed this. So if the test is two-tailed test, then the p-value is this region and this one. So that's mean the probability of z greater than absolute value of z0 or z observed. They said z0 or we said z observed. or test statistics. They say Z0, the test statistics. Yeah, so this is for two tail, 2 times of this. Because if you calculate the probability of Z greater than absolute value of Z0, that's mean you are calculating this area. But the p-value is this area plus this area. So that's why, and this area and this area are same. So that's why we did 2 times of this one. This is the p-value for two-tail test. For left tail, the p-value is this one, probability of Z less than Z0. And for right tail test, the p-value is probability of Z greater than Z0. Z0 or Z observed, whatever it is. Okay, value of the test statistics and p-value. So here the value of the test statistics is Z negative 1.19. So the p-value is Z less than negative 1.19. So this is the p-value here. Okay, so here are the general steps for the p-value approach to do hypothesis testing. So step 1 is state the null and alternative hypothesis. Actually, this is same for critical value approach and p-value approach both. So you need to state the null hypothesis and alternative hypothesis. So this is the first step of hypothesis testing, and this is the important step of hypothesis testing. Yeah. Decide on the level of significance. So then you need to decide the level of significance. So what is the value of alpha? Then we need to calculate the value of test statistic. Then we determine the p-value. We compare the p-value. If p-value is less than equal alpha, we reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. Then the last thing is interpret the result of the hypothesis test. So this is also very important to know. How do we interpret the results of the hypothesis test? I'll discuss this one later. Okay. So based on the p-value, we can categorize the evidence against the null. So if the p-value is greater than 0.10, then we can say this is weak or none. That means there is no evidence against the null. If p-value is large, that's when we fail to reject. If p-value is 0.05 to 0.1, then we say this is moderate evidence against the null. And if p-value is between 0.01 and 0.05, we say a strong evidence. That's mean we have a strong evidence to reject the null. And if p-value is less than 0.01, this is very strong evidence to reject the null or against the null. That's when we reject the null hypothesis. Okay, so hypothesis test without significance levels. So if the significance level is given, then we'll compare the p-value and significance level, and we'll make our decision. And many researchers, they do not use the significance level. They just calculate the p-value, and based on the p-value, they see whether the p-value falls. If p-value is this one, they say there is no evidence. If p-value is between these two numbers, they say there is moderate evidence. And if p-value is between these two numbers, they say strong evidence against the null. If p-value is less than 0.01, they say very strong evidence against the null. But if the level of significance is given, in that case, actually, we do not make our decision like this. We just say reject or fail to reject. We do not say whether it is strong or very strong or moderate or no evidence. Okay, so we'll go over some example. The p-value for a hypothesis test is 0. So the p-value is 0.082. And part A, alpha is 0.05. So this is our level of significance, and this is the p-value. So what should be our decision? So should we reject or fail to reject null? So compare the alpha value and the p-value and make your decision. So what do you think? So should we reject the null hypothesis or fail to reject the null? Okay. Yeah, we fail to reject the null, right? Because the p-value is greater than alpha. So here the p-value is greater than alpha, right? This is 0.082, which is greater than 0.05. So we fail to reject null hypothesis. So we fail to reject null hypothesis in this case. And okay, we have in part B, the alpha is 0.10. So in this case, the p-value is less than alpha. So that's mean in part B, we reject the null hypothesis. We reject null in part B because p-value is less than alpha. So we reject the null hypothesis. So we have one more example here. The test statistics is in a right tail test is z equal 1.46. So the test is right tail test. So draw the normal curve. Okay. So here the test statistics is z0 is equal 1.46. So this is given. And level of significance is 10%. So alpha is 0.10. So that's mean this is the critical value, which is z alpha, which is z 0.10. Now we need to find the critical value. So yeah, that's fine. We do not need to find right now. So alpha is 0.10. So now we need to calculate the p-value. So this is right tail test, right? It is given that the test is a right tail test. So that's mean the p-value is probability of z greater than z0. So that's mean probability of z greater than 1.46. So if you look at the z table, and if you look at 1.46 or negative 1.46, you will get the number. And the value is 0.072. So the p-value is 0.072. So we found the p-value, and we have the level of significance, which is 0.10. Now compare these two values. So the p-value is less than alpha, right? Because 0.072, which is less than 0.10. So that's why our decision will be, we'll reject the null hypothesis, right? We'll reject null in this case. Do you have any question? Okay, so in part B, the test statistics in a right tail test, this is also right tail test, and the test statistics is negative 0.67. So alpha is 0.10. So here, this is our test. So this is z alpha, and this is z 0.10. So since this is right tail test, we need to find the probability z greater than, this is z0, z0. So that's mean z greater than negative 0.67. So from the z table, this area is 0.749. So if you look at the z table, and if you look at this number, and you know how to find the probability from the Z table. This is just probability of Z greater than negative 0.67. So which is 0.749. So here the p-value is way larger than the alpha value. So that's mean we fail to reject the null hypothesis in this case. Fail to reject null. Okay. So we have another example here. The test statistics in a left-tail test is Z equals to negative 2.40. So this is the test statistics. Z0 is negative 2.40. And this is left-tail test. So alpha is 0.10 because the level of, oh, sorry, not 0.10. This is 1%. So that's mean alpha is 0.01. So 1% is 0.01. So since this is the left-tail test, so the p-value will be probability of Z less than negative 2.40. Now we have the partial Z table here. So negative 2.4 is here, and 40, that's mean the first one. So the area is 0.0082. So the probability is 0.0082. So which is smaller than the, oh, sorry, this is not Z, this is alpha value. Okay. So that's mean the p-value is smaller than the alpha value. So we reject the null hypothesis. So in this case, we reject the null hypothesis. Do you have any question? Okay, thank you. Yeah, if you do not understand anything, or if you have any confusion, please ask me. Yeah, don't hesitate to ask me. Yeah. Because we'll be using the same concept in the later chapters. Okay, so the test statistics in a two-sided test is, so we have the test statistics in a two-sided test. So which is Z equals to negative 1.77. So we have to find the p-value. So for two-tailed test, the p-value is probability of Z greater than absolute value of Z observed. So that's when probability of 2 times of this, actually 2 times of this. This is the p-value. So if you take the absolute value of negative 1.77, then it will be 2 times of probability of Z greater than 1.77. So which is 2 times the probability of, where is negative, where is 1.77? So this is 1.7 and this is 7. So this value is 0.0384. Okay. So now the question is, you can ask me why we are looking at the negative number. Actually, the normal curve is symmetric, right? So this is 1.77 and this is negative 1.77. So if you look at this number, you will get this area. This area is same as this area, right? And we are actually here, we are looking for actually this area. But in the table, we have all negative numbers. So the idea is, if you look at the negative number, you will get this area, which is equal to this area. So that's why you do not need to even look at the positive number. So if you look at the negative number, the area is 0.0384. So 2 times 0.0384. Then it will be 8. .0768. So what is the value of alpha here? Alpha is 5%. So since this is two-tailed test and we calculate the probability for two-tailed test, so we'll compare with the alpha. So alpha is 0.05. What you can do, even if you do not want to multiply with 2, then you can compare with alpha over 2. That will be the actually same thing. So alpha is 0.05 and p-value is 0.0768. So here p-value is greater than alpha. So that's when we fail to reject the null. So in this case, we fail to reject null in this case. Okay, so that's all about section 9.3. So today we learned two things of the hypothesis test. One is critical value approach and the other one is p-value approach. And we also know the relationship between critical value approach and the p-value approach. They are actually doing the same thing, and based on these two approaches, we'll have the exactly same decision. The only difference is for p-value approach, we calculate the p-value and compare with the alpha value. And in critical value approach, we do not calculate the p-value. So we calculate the critical value and the test statistics. So we compare these two values. Okay, so we have two more sections in this chapter, section 9.4 and 9.5. So in section 9.4, we'll discuss about hypothesis test for one population mean when sigma is known. So that's mean actually in the chapter we are considering sigma is known. The parameter, this standard deviation is a known value. This is not unknown. But in the next chapter, we'll discuss where hypothesis test where S will be used to estimate the value of sigma, where sigma is unknown. But in this chapter, sigma is known. So that's why we are doing z-test. Okay, so for one mean hypothesis test, to perform a hypothesis test for a population mean mu, so we need to satisfy the following assumption. First, we need to check these three assumptions. The first one is simple random sample. So that means the data are independent or they are collected independently, independent random sample. So number two is normal population or large sample. So that means the original distribution is normal distribution or the sample size n is large. And third assumption is sigma is known. So this is the key assumption in this chapter. Sigma is known. That's why we are using z-test. And here are the steps to perform a hypothesis test. Step one is the null hypothesis is H0. This is always H0 is mu is equals to mu0. Mu is equal a specific value, a particular value. So, and we can have also different null, but in this course, we'll just go with this one. Mu is equals to a specific value. And the alternative hypothesis, we can have three types of alternative hypothesis. This one, this one, this one. And based on this, we'll determine the tail of the test. So step two is decide on the significance level. So the first thing is you will write the null and alternative, and you will determine the tail of the test. The step two is decide on the significance level, alpha. So that means you have determined the value of alpha. And step three is compute the value of test statistics. And which is z is equal x bar minus mu0 sigma over square root of n. Usually we denoted it by z observed, or you can say z0. This is the test statistics. Okay, number four is making the decision. So now we know two approaches. One is critical value approach. The other one is p-value approach. So for critical value approach, you will calculate the critical value for two-tail test, which are negative z alpha over 2. And for left tail, you will calculate negative z alpha. For right tail, you will calculate z alpha. And for p-value approach, you will calculate the p-value. p-value for two-tail test, for left tail or for right tail test. And in step 5, for critical value approach, you will compare the critical value and the test statistics. If the test statistics falls in the rejection region, you reject the null, otherwise fail to reject the null. And for the p-value approach, you will compare the p-value with the alpha value. If p-value is less than equal alpha, we'll reject the null hypothesis. Otherwise, we'll fail to reject the null hypothesis. And the last thing is, the very important step is interpret the results of the hypothesis. So finally, we'll interpret the results in the context of the question. Okay, so now we'll discuss when to use the one mean z-test. So when do we use z-test, one mean z-test? Okay, so if we have a small sample size, actually this is similar to the confidence interval. So for a small sample size, say sample size less than 15, the z-test should be used only when the variable under consideration is normally distributed or very close to being so. So that's mean only when the population is, we know that the population is normally distributed or very close to normal. And for samples of moderate size, if we have a moderate sample size, so that's mean the sample size between 15 and 30, then the z-test can be used unless the data contain outliers. If it doesn't have any outliers, or the variable under the consideration is not far away from the normal distribution. That's mean the distribution of the variable is not like this, or is not like this, or is not like this. So it should be bell-shaped distribution, something like this. Yeah, symmetric and bell-shaped. If the sample size is between 15 and 30. So for large sample, regardless of the distribution of the population, if the sigma is known for a large sample, that's mean if the sample size is 30 or more than 30, we can use z-test without any restriction. But however, if outliers are present, if there is outliers and their removal is not justified, we cannot remove them, then we'll perform the hypothesis test with outliers and without outliers, and we'll see whether we have different results or same results. So if we have different results, then we need to think about this. We need to think about whether we should use z-test in this case or not. But if we have same results with removing outliers and without removing outliers, then we can use z-test. So it will be okay. Okay, so I think I should stop here, because we're not going to do hypothesis test today.